Hello everyone, it is January 19th and today I'm going to be doing problem 3217, delete nodes from linked list present in array. So let's get started. You are given an array of integers, nums, and the head of a linked list. Return the head of the modified linked list after removing all nodes from the linked list that have a value that exists in nums. For example, we have values 1, 2, and 3 in nums, and the head actually begins with a node that has the value 1. But we still need to remove it. Well, we need to remove that value from the linked list, as well as 2 and 3, resulting in returning the head of the modified linked list, which would be 4, 5. Just a quick thought that came to my mind is that if we're removing the head of the modified linked list, then it doesn't necessarily mean we need to remove these nodes with these values, but if we just change the head pointer from initially 1 and we traverse over to 4, the node 4, then we can return 4, and therefore technically we are returning the head of the modified linked list. Although it wasn't really modified, this is acceptable, though I'm not sure if that's going to be a valid solution for all examples. So let's continue. Example 2 has nums 1, and here we see there are multiple nodes with a value of 1. And so, as I said before, example 1, the solution that I kind of gave, won't work for that at least. So we remove the nodes with value 1, here, 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 and we return the head node of 2 right here. And now the head node's next node is no longer 1, it needs to be 2. Similarly, this node's next node needs to be 2, and the one node that it was previously pointed to, they need to both be removed. In example 3, we have nums 5, and the num 5 isn't actually located in any of the node's values, so returning the head node as it was originally given is acceptable. All elements in the nums are unique. There's guaranteed to be at least one node. The input is generated such that there's at least one node in the linked list that has a value not present in nums. Okay. So my next immediate thought is it wants us to return the modified linked list, but do we necessarily need to even modify it? Could I create nodes and then if the value of the node that we're currently on, if we traverse from the head node all the way to the tail node, and then we create a separate node, and then if the value of the head node is value in nums, then we won't make the other node we created's value that value, and instead we'll still keep that node. Let me make some notes actually so I'm not just talking. We create another node, and then we have the linked list that we're given beginning at 1 node, beginning at the node with a value 1. and we know we can't have any ones in our linked list, so we can even create a set containing one, containing every value in nums. And if the node that we're currently on has that value, then we don't modify the node we created. It's currently no value and no next pointer. And then we traverse on through the linked list, going to 2. And 2 is not in nums, so we can then add the value, or excuse me, change the value of the node we created to be 2. Still, there's no next pointer, but we move this node over in the linked list. So we go to the next node, and it's 1. Once again, we can't use that node, so we go to 2. 2 is valid, so we point our next pointer within the first node to a new node with a value equal to 2 and a next equal to none initially. One thing we'll have to do is we'll have to create a dummy node that points to the that's equal to the head node we created. This is the head node. We continue traversing through the linked list. Once again, 1 is not added, 2 is added. And one other thing we have to do is we have to set the current node that we're on within the node, or within the created nodes. We have to move that over to the next pointer. So now the current node is the node we created second, and now we have the value 2, and we create another node. Next equals to node value equals to 2, next equals to none. Move the current value over to the next node, and then we see we're done with the linked list. And now we can return the dummy node, which is the head node of the created linked list. So that's a decent solution. It does cause some extra space because we're not modifying the linked list, but instead we're creating each node, and so that could be a little bit of an issue. Time complexity is not bad because we just have to, the time it takes is just the time it takes to iterate from the first node to the tail node to ensure that we're only adding nodes that are valid, that do not have the value within the nums array. So that's an O of n time complexity in a worst case, but the space thing is the real trade-off with that. So let me think of another solution, one that we could potentially just modify the linked list and save space. Okay. Okay, the other thing I'm thinking of is we have the linked list that we have all the values, that some values we need to remove. So what if instead of creating new nodes, we store these values in an array. The values that can be used. So 1 can't be used, but 2, the 3 2's can be used. So what if we traverse through the linked list and put every value into an array? And then these are the only valid values. And then we traverse the linked list again. And instead of, we traverse it, and then we can just change the value one at a time. So say we have an index initially pointing to the 0th index in this array of valid values, and we have the head node. We have the head node, and what we can do is we can create a current node equal to the head node, and then we can iterate through each value in the valid values array, and we can iterate through the linked list while an index initially equal to 0, while index is less than the length of valid values array. And the current node exists. Then we can just change the value inside of the node. So current node.val equals to valid values index. And then we'll move the index over by 1 value, or by 1, just by 1. So now we're at the first index. And the current node will equal the current node.next. Okay, so that's good. So let's see here. So this is the valid values. Let me write that for a little clarity. Valid values. Linked list equals to initially at the head node. We've modified that to now equal to 2. We move over by 1. If the value of the node value already equals to the valid value, then we move both of them over. Now index would be at index 2. Current node goes to the next node. Does the current node value equal to 2? No, so we change it. And now valid values, the index that we were traversing through the valid values is now outside of the array. So then we break out of this loop. And we'll also create a previous node equal to none. And then we'll set previous node equals to current node. So previous node will be pointing to this node. I'll just say previous. Current node is now at 2. So once we've escaped this loop, previous node will still be here, and we won't be traversing through the linked list anymore. And the reason why I'm doing that is because we want to remove all the nodes from the linked list that have the value that exists in nums. And because we modified the linked list in a way that we've preserved the space that it took to create the nodes initially. Well, we didn't create them, but they were already created. But we still need to remove the remaining nodes so that we don't return the head of a node that has invalid values at the end of it. So after this loop, we'll say previous node.next equals to none. So what that does is all these nodes, they still exist, but they won't be a part of the linked list we're returning, because our tail pointer, which is this 2, is no longer pointing at anything. Okay. So I think that's pretty good. There was one additional thing that I didn't write in my notes that I kind of just talked about, and that's if the linked list value equals the valid values, then we move the pointer of the linked list over by 1. But I suppose it doesn't matter. We still need to move both the pointer and the valid value. So I think that's irrelevant. And current node equals to current node.next. So let's see, is that okay? Previous node equals current node. Let me go back a few spaces. Previous node equals to current node equals current node.next. That'll keep traversing though, so I need to modify that. Previous node equals to current node equals current node.next. So that's C. But this condition still exists, but because we're at the end of the array, the valid values array, we can no longer traverse. So this will break, and then we can modify that pointer, the next pointer. So that's okay. That all looks good to me. So the only thing left to do is to implement this. And I think that this is a better solution because technically the problem statement does say return the head of the modified linked list. And so we're actually modifying it. We're not just doing kind of a trick by traversing through and what was I going to say? But I wasn't going to use that solution anyways, so that doesn't really matter. Oh, excuse me. My other solution of actually creating the nodes one by one with each value with each valid value. So that's another solution, but not very practical. This one saves on space. Time is still the same though. Okay, the first thing we need to do is collect all of the values from the linked list given. Valid values equals an array. Node equal cur equals head, while cur valid values dot append cur dot val cur equals cur dot next. And now we have the values. And we also need to create a set. Num set equals to set of nums. Wait a second, I'm getting a little bit ahead of myself. So I need to create the num set so that we check if the value that we're currently on in the linked list is valid. We just check it within the num set, but I don't even need to do that though. I just get all the values from it. Valid values.append cur.val. But the ordering of it matters. Valid values.append. So I'll only append it if cur.val not in num set, then we append the value. And so the relative order of the nodes we need to add, which are 4 and 5, are still added to the valid values. And the ones that are in the num set are not, but we're still traversing. Okay. Okay, and then cur equals head again. We're pointing it initially to node 1 again, as we previously did, but we don't, yeah, that's pretty clear. Index equals to 0, while index is less than length of valid values. The nums array is guaranteed to be at least 1. Okay. So it's not like we can just return we can return the linked list if there are no values in nums, because there's guaranteed to be at least 1. So that base case is out. While index is less than valid values and cur am I running into an issue there? If there's multiples of the same value in head. No, because it worked for this example. Okay. If no, cur.val equals to valid values index. Cur equals cur.next. We also need to bring in a previous pointer. Previous equals to cur. Cur equals cur.next. Index plus equals to 1. We break out of the loop once there are no more valid values. And then previous.next equals to none. Previous, yeah, yep, that works. And then the head is still the same. So can't we just return the head node? regardless if the value is equal to or not equal to the valid values index, we're still setting it to it. If it is, it doesn't change anything. Previous gets updated to cur. Cur goes to the next pointer. Index moves over by 1. I feel like I'm missing the condition if, what if, can cur be equal to none and the index is not less than the valid values? What would I do in that case? I need to add the valid values regardless. No, it can't, because cur can never, valid values will only, I suppose valid values is even improperly named. I should just say values to add. Let me just change that. Change that to node values. Cur.val equals node values of the index. One gets changed to 4. We move over. 2 gets changed to 5. We move over to 3 in terms of the current node, but we're outside of the while loop. Previous.next equals to none. We remove the pointer and then return head. Head is still modified. Only 2's are added to the node values. That works as well. And then nothing gets changed here. That all looks good to me. I want to make sure that the pointers are correct as well. I can just return the head node. Return the head of the modified linked list. That looks good to me. Fantastic. Not fantastic because of the runtime, but I'm happy I solved it on the first try. The memory is interesting. I'm not creating any additional nodes. And the space is still O of n. You have to traverse through the linked list at least, yeah, from front to, or from head to tail at least once. I know that. So that's 2 to the n, or 2n, which gets reduced to n. And then the space is for creating an array of node values. Yeah, I'm trying to think of any interesting ways I can remove some space, but I need the num set as well. Okay, well, I'm satisfied with that. Let us enter it into ChatGPT to see what they think. Yeah, this is what I was thinking a minute ago. Is it doing it in place? Mutating node values is not ideal. And this is another line that it is open to interpretation in how strict you want to be with a problem statement. It breaks the semantic meaning of nodes. And realistically, changing values like that is unsafe. The dummy node is something I've done in previous problems, and I was considering. Previous.next equals to current.next. I see. So that removes the node in between and it points at the next node. Else, we just move previous to the current node to the next node. Okay, that's valid. That's pretty good. If every node is deleted, then previous equals none, previous.next equals to none. I see. But our constraints make this never happen. So we don't need to worry about that. Yeah, this solution is definitely more straightforward and less space, so that's always good. So I'm going to have to reconsider using this dummy node because I have done that before, but it's been a while. So it was in the back of my mind, just pointing to the next node, I didn't really think of that. Previous.next equals to the current.next. But you could still move the current over. Yeah, that's interesting. Okay, well, that concludes this problem. Thank you all for joining me. I hope you're having a fantastic day. I had a nice little vacation this weekend, but I ended up having a phone call with a recruiter today for a software engineering role, and now I'm just have to schedule an interview for within the next couple weeks. So that's exciting for me. I hope you all have a fantastic rest of the day if I haven't said that before. And, keep going after your goals, guys. We're all in this together.